right, in this video we're going to talk about domain and range, intercepts, increasing, decreasing, and end behavior. So domain and range we should have done in Algebra 1. We need to know that the domain of a relation or a function represents all of the possible x values for the relation or function. So the key there, domain, is the x's. The range of a function is all possible y values for the relation or functions. So for the range, we're thinking up and down, the y values, whereas for the domain, we're thinking left and right, the x values. Your intercepts are where you touch axes. So a 0 is the x value where a function touches the x-axis. So if I make myself a coordinate here and I have an x and y axis, then right here where I touch the x-axis, I can touch more than once if I want to, that is a 0 or an x-intercept. So zeros and x-intercepts are really the same thing, but typically I'm going to write a 0 as an x value, and I'm going to write an x-intercept as a coordinate where a function touches the x-axis. The y-intercept is the coordinate where a function touches the y-axis. So down here where I touch the y-axis would be my y-intercept. All right, increasing, decreasing, and constant. We can describe how a function is changing. So we're going to say where a function is increasing, decreasing, or constant, we have to work from left to right, the same way we would read. So while we're doing that, if the y's are getting bigger, the function is increasing. So if I'm drawing from left to right and I'm going up, I'm increasing. If the y's are getting smaller, so as I go from left to right, I'm going down, I'm decreasing. If the y's stay the same, so if I'm nice and flat, then I'm called constant. I'll look at how to write that later. The end behavior as a function. To describe a function's end behavior, we look at what the graph is doing on the far left and on the far right. So where is it going? Most of our graphs have arrows, and we'll say what they're doing. So for the right end behavior, we consider very big positive x's, because if I were to make an x-axis, here's the right. On the right side of the graph, I have very big positive x's. I'm going to call that infinity. As x approaches infinity is what I'm going to write for the far right. I write a little arrow and call it approaches because I can't say you equal infinity, because that's the whole idea. You'll never get there. So then we have to look at what's going on with the y's. And the y's were going up and down. So if the y's are going up, that's going to be up at the top. So then we'd say the y's are approaching infinity. If the y's are going down, that would be on the bottom of the graph, in which case the y values are negative, and we would say y approaches negative infinity. We also have the left end of our graph. So on the left end behavior, we're looking at very big negative x's. So on the left side of my graph over here, my x's would be heading towards, whoops, I moved, negative infinity. And again over there, if x is going to negative infinity, we're going to write that with x approaches negative infinity, a little arrow. And if the y's go up, y goes to positive infinity. If the y's go down, we say y goes to negative infinity. So here's some steps for analyzing a graph, and we're kind of going to do this on this first example down here. Sorry for that flicking. All right, so first thing I want to do is I want to take my graph, and this graph right here is the function f of x equals x squared. And what I'm going to do is I'm going to label any endpoints. My graph does not have any endpoints. Endpoints would be like on the endpoint of a square root function. I need to label that point. I'm going to label the turning points. Turning points are places I turn around. My graph has one turning point right here at the origin. Its coordinates are 0, 0. I'm also going to label where the arrows are going. Now, in order to label arrows with coordinates, I have to be careful, because this arrow right here, it's not on a specific coordinate. It's just telling me which direction I'm headed. So for an x value, I need to think, is this arrow headed over here towards the right or is it headed over here towards the left? This arrow is headed towards the right. The right is a positive infinity, so we're going to call its x value positive infinity. Then I need to write the y value of this arrow. The y value is up and down. If y is headed up like this arrow is, it's headed towards positive infinity. So my coordinates for this arrow, even though they're really not number coordinates, are going to be infinity, infinity. Now I have another arrow over here on the left side of my graph. So for this one, the arrow is pointing to the left. The left is over here towards negative infinity in the x direction. The arrow is also pointing up, which was positive infinity, in the y direction. So I just labeled the key points in my graph. Okay, so I erased the extra stuff I wrote, and now I'm going to do the domain. The domain goes from the smallest x to the largest x. So remember, domain is x values. So I'm going to start with the curly brackets, and I'm going to say x. So what's happening with x? Well, the smallest x, or the leftmost x on my whole graph, would be negative infinity. I also have an x at 0, and I have a biggest x over here at positive infinity. So if I can be anything between negative and positive infinity, that means I can be everything. And I'm going to write x is an element of the real numbers. And that's how I write it in notation. I could also write the words all reals. Or if I wanted to, I could say x such that, which is a line, and then I can sandwich an inequality with my smallest x, which is negative infinity, my biggest x, which is positive infinity. If I were to write a symbol between them, a less than or greater than, it would be a less than symbol. And I'm going to say negative infinity is less than x, which is less than infinity. I typically use this one right here, but you could use the other two as well. All right, let's do the range. For the range, I'm looking at the y values of my function. I want to go from the smallest y value to the largest. That means the lowest y value, which was down here, to the highest y value, which could have been on either one of those points because they were both positive infinity. So for my range, if I'm starting from 0 and going up, I would probably write y such that y is greater than or equal to 0. I need to put the equal to on that one because I'm allowed to equal 0 for y. The other way we could write this is we could say y such that we could choose the smallest y, which is 0, the biggest y, which is infinity, and then put the y in between in the inequality. 0 is less than infinity. I need to put an equal to sign because that was a solid point I was allowed to equal. And I need a less than symbol there for the infinity. I don't put an equal to sign on that one because I'm not allowed to equal infinity. So the whole idea is I'll never get there. All right, the next three things sort of go together. They're the intercepts of our function. So to figure out my intercepts, I need to remember what that vocabulary word is. I need zeros and x-intercepts are the same thing. That's where I hit the x-axis. I do that one time. It was right here at 0, 0. I usually write my x-intercept as a coordinate 0, 0, whereas when I write the 0, I write x equals 0, and I just put the x value. It doesn't have to be one way or the other. You'll just need to read the directions when you get to them. The y-intercept is where I touch the y-axis, which in this case is the same place. It's at 0, 0, and I'm going to write that as a coordinate also. Next, I want to do my x intervals for increasing, decreasing, and constant. So I'm going to break the graph into zones as I travel from left to right. It's really important I'm going from left to right. Then I'm going to describe the zones by the x values. They always have to be x values. The y coordinates are never used. The intervals are written where I say the left x value is less than x, which is less than the right x value. So kind of like this notation I used with my domain. All right, so if I'm looking at this function right here, and I'm starting out on the left, it's right up here at this arrow. As I travel to the right, I'm going down, which means I'm decreasing. So for this first part of the graph, it's decreasing. Next, I switch and I start traveling up as I'm going from left to right. That would be increasing. Now I need to write those two intervals. So starting with my decreasing interval, I need to use the x values for this piece over here. My left x value was a negative infinity, and my right x value was a 0. So I'm going to write down, oops, I was decreasing, from negative infinity to 0. In between, I need to put some inequalities. Since negative infinity is less than, I don't know why I just switched there, I need to put a less than symbol, another x, and a less than. All right, next I have the piece where I'm increasing. I was increasing over here on the right of my graph. Again, I have to use the x values of 0 and the x value of the arrow, which is infinity. So the 0 goes first, and then the infinity goes on the right. 0 is less than infinity, and infinity is greater than 0. So I can write it like that with two less thans, and the x goes in the middle. Oops, that's constant. Let me move that up here. That was supposed to be where I was increasing. Okay, where am I constant? Where am I flat? Never. I'm never flat in this graph. Okay, now we need the end behavior. So for my end behavior, I'm going to write it as x approaches something, y approaches something, where the blanks are filled in by our coordinates of the arrows. I put quotations there because these aren't real coordinates. They don't have numbers. They're infinities. So as x approaches infinity, that means I'm looking for an x value of infinity, which is the right side. What's y doing? Y is also infinity, so I put an infinity in this blank. On my left arrow, I have as x approaches negative infinity. That was over here. When x was negative infinity, y of that coordinate was positive infinity. So what this is telling me right here for my top thing, as x approaches infinity, that means on the right, and then I have y approaches infinity. Y goes to infinity means up. So it is up. Then I have my second part as x approaches negative infinity. X is negative on the left. So this one's saying on the left, and for our second part, we have y approaches infinity. If y's are positive, that means they are up. So on the left, it is up. All right, so that was our first function. I know it's going to take a few more till we totally catch on to this. So let's try another example. So again, I have example 2 on the next page. I need to give all the information. So the first thing I'm going to do is I'm going to label the coordinates of the end point, which the coordinates of that guy. So that point right there was at negative 3, 1. Then I've got this turning point, which is at negative 1, negative 1. I've got this turning point where my graph sort of changes shape. That one is at 2, negative 1. And then I need to describe my arrow on the end here. This arrow, the x value is headed towards the right, which is positive infinity. And the y value is headed up, which is positive infinity. So both the x and the y values of my arrow are going to get an infinity. All right, so the domain from left to right. What's the leftmost point on the whole graph is this end point right here. His x value is negative 3. It goes forever to the right. So I could say x such that x is greater than or equal to negative 3. The range is talking about the y values. So now I'm going to look at all my y values. So I have a negative 1, I have a negative 1, I have a positive 1, and I have an infinity. So the smallest y in the whole graph is at either of those 2 points, and it's at negative 1. So I want to say y such that y is greater than or equal to negative 1. Okay, my zeros and my x-intercepts are where I touch the x-axis. I do that in 2 places on my graph. For the zeros, I state them as x values. So my first point was that x is -2, and my second one was that x is +4. To write the x-intercepts, I'll do those same 2 points written in coordinate form. So -2, 0, and 4, 0. To do the y-intercept, I want to say where I touch the y-axis. I can only touch the y-axis once and still be a function. The y value where I touch is at y equals -1. To write that as a coordinate, it would be 0, -1. All right, let's do the intervals. So for increasing, decreasing, and constant, remember that I have to go from left to right. So I'm going to start at the leftmost point on my graph. As I'm traveling to the right, I was going down. So for this first part, I'm going to say I was decreasing. Then I have my next piece. From here, I was flat. So for that piece, I'm going to say I'm constant. Then my function starts to turn and it's going upward. So for this piece, I'm going to say I'm increasing. It helps me to state I'm decreasing, then constant, then increasing, so I can make sure I get my intervals in the right place. Now I want to talk about where these things are happening. So this is where I'm decreasing. I need the x values between which I'm decreasing. So I'm going to go to my decreasing place, and I'm going to say the leftmost point, the x value was -3. The rightmost point, the x value was -1. Between them, -3 is less than -1. I also need my x and my second less than to say -3 is less than x, which is less than -1, or that also means for any values between -3 and -1, my function is decreasing. On my next piece here, I was constant. The x values for this piece went from -1 to +2. So in the constant space, I'm going to put a -1 and a +2, and in the middle, I have my less than x less than. My last piece on the right here was increasing. The x value where I started was at 2, and the x value of the arrow was infinity. In between, I have my less thans and my x. So those are my intervals for increasing, decreasing, and constant. Last, I need to put up my end behavior. For these, I'm looking at my arrows. I have an arrow where x is going to infinity. That's this arrow over here on the right. When my x was an infinity, my y was also a positive infinity, because as x went to the right, y went up. Now for the second thing, it's asking me as x goes to -infinity. I don't have an arrow pointing over here on the left side of my graph, so x doesn't go to infinity. I'm just going to write NA right here. I could, if I wanted to talk about the left side of my graph, say as x approaches -3, y approaches 1. So this would be an option, and we'll do a little more with this where we have numbers involved later, but for right now, we're not going to worry about it. Okay, right now go ahead and pause the video while you try and fill in example 3, and then you can check your answers and see how you do. Okay, here are my answers for example 3. Notice I gave more than one answer for how to write the domain. I would have used this one, x is all reals and y is all reals. You could have done one of the other 2 options as well. For the rest, there's primarily one way to write it. So you can check those over. Notice this one in our increasing had 2 intervals. So I just put both intervals with a comma in between them because I was increasing going from left to right on both this piece and on this piece. If you still have more questions on this, you can come to class with them next time. You can go ahead and pause the video and then you can try to do the examples on the next page. I will scroll through those in a second, but don't just write down what I have. Try to figure them out on your own and then check yourself. Here are your answers for number 1 and number 3. You can pause the video while you look at them. Here are your answers for number 2 and number 4. Again, just pause the video so you can look at them as long as you need to. Finally, here are your answers for number 5 and 6. Go ahead and pause the video while you check them, and we'll do some more practice with this in the coming days in class. Be sure you keep your notation right.